Hello everyone, welcome back to my course Sustainability for Future Generations Concepts, Technologies and Global Practices. Today we will discuss about the session module number 3 Sustainable Waste Management and Resource Recovery. Myself Dr. P. Swaminagar Ratnagiri, Associate Professor, Department of Civil Engineering, SR University, Warangal. Let me go to the outline of this session. So, outline of this session we will go with the introduction to the waste management and its importance, and what could be the principles involved in the sustainable waste management. So what could be the hierarchy we have to follow for the waste management. So what is the compositions and types of waste involved in this waste management, and how we are going to segregate and collect the systems will be adapted. How what are the recycling technologies we can adopt, that is compositing anaerobic digestion system. And then we'll go for the resource recovery and circular economy aspects in this solid waste management, that is sustainability. So we can integrate what are the challenges and policies should be integrated. So what are the digital AI technologies for the future trends. Then we'll go for the case studies and summary of the session. You can see this image was clearly mentioned. So the steps involved in the waste management was generated, and then it was to be segregated at the source. So most of the cases we can segregate up to 15 but 55%, whereas 27% is not going to be done in globally. Then this 58% was gone through the collection of various bags and dry waste and e-waste. Then you will go for the transportation of trucks and 27% like this. Then what could be the recyclable material and non-recyclable material? We will be estimating about that incinerated where landfill or RDF. Then waste we are going is the dry waste, and we are coming to the wet waste. So wet waste will be 63% can be recyclable as the global prospects, whereas the dry waste can be recyclable about the 81%. So non-recyclable waste, which is going to be landfill and incinerated as well as the RDF. So let's go to the one of the important points. So why sustainability waste management is required in sustainability aspect as per SDG goals. When you are integrating it to the minimizing the waste generations from various industry, which can we recover the materials, energy as well as the nutrients. So these are some of the things where we have to keep it mind when you are thinking about the managing of this waste generated from various industries. So what are the main objectives of this waste management was to prevent the waste generated from various industries and promote the reuse and recycling, recover energy and nutrients, so minimize the environmental impacts. Then public health is one of the important criteria. You see has clearly what sort of waste are generated from the municipal solid waste, or it may be industrial waste or some other industries or agriculture waste. It may be divided into several parts. One is the glass waste or metal waste or paper waste or else organic waste and also plastic waste. Whereas the e-waste is the electronic waste. As we discussed in the circular economy, how we can reuse, recycle and remanufacture or reproduce. So in this waste management is one of the best practices where we have to involve different segregation process as well as processing and collecting the waste which is generated from different industries or municipal authorities. So coming to the global crisis, the numbers which is clearly mentioned here. So 2.24 billions of the global municipal solid waste up to 2020 was estimated. It was clearly understand how we are understanding the scale of challenge we have to go through it. In this one, we estimating the projected municipal solid waste is one of the most threat one where you have to concentrate on, and we have to think about the research on this. Oh, important point is about the municipal solid waste. In this 2.24 billion, which is come from your the global municipal solid waste, which is projected in the 2050 maybe 3.8 to 3.9 billions. So where in this one globally plastic recycling rate is only 10%, whereas the cost waste management is about the dollars was about $100 per billion. So coming to the Indian statistical condition about the different waste produced. So here municipal solid waste is like coming under 1,60,000 tons per day. So as per the CBSP report, then one of the highest globally, where we have to think about the two major impact on the municipal solid waste as the biomedical waste. These are some of the two highly impactable waste which is coming from daily usage. So biomedical waste is around 743 tons per day, which you have to think about the research about this two in a proper way. Then you have to reduction, how we can reduce this waste. Then next one is how we are going to depend upon the per capita generation, rising with urbanization, raising with the urbanization policies, and recycling rate, how much amount of recycling rate was established here. So large gaps are remain here, maybe especially in the tier 2 and 3 cities. So waste generation varies from low to very high amounts. So when you keenly observe that Indian biomedical waste is around 740 tons as per day of in 2023, whereas Indian municipal solid waste comes under 1,60,000 tons. As we discussed globally, this is 2.2 billion tons. Where is the concern you have to give about this to waste which is coming? So we have to think about how to recycle and manage collection and process this two different types of waste. So coming to the three major categories of the waste, as we discuss what sort of waste are generating globally. When you see household or a solid waste management is called municipal solid waste. So we have to think about in a clear cut manner how we are going to um, get into the food scraps, organic matter, and paper, cardboard, plastics, and glass metals. E-waste come the batteries and gadgets which are utilized in the at home. Green garden yard waste, it is a biomass. So then industrial waste is like fly ash, slag from the power plants, and chemical effluents which is released from the open source drainages, and construction demolished waste, debris, textile and leather effluents, packing and manufacturing waste, and chemical industries as well as the fertilizer industry. There are several lot of industries which is coming waste which is generated. We have to think about how we can recycle and reuse, and think about the triple bottom line, and you have to think about the three basic important parameters: socio-economic conditions of the three pillars of the sustainability, that is social, economic and environmental consideration you have to give. So coming to the biomedical waste, there's a lot of scrap will be, sharp needles will become, infections will come, and the pharmaceutical waste will come, anatomical pathological waste will come, chemical and symbiotics waste will come. So these are also important, high impact is there in the globally. So we have to understand how we can recycle this sort of waste in a better way, and you have to think about the we cannot throw it on the lands, where we have to think about in a better way. That is one of the best way to thinking and processing about this waste. So then we have the waste management methods. When you think about the waste management methods, so once we have to think about how to source segregation method is adopted. So separate the waste different categories to recycling. This reduce the contaminations of recyclables. This is one of the important parameters at the first step. Priority was given to this, how we are supposed to get the final product. When you have the metal recycling, so once the metals are sorted, are clean and processed and remade, so contaminated plastics may face lower value of recycling. So metal recycling will be started here. Then when you start it carefully, then we have the organic recycling, which should be used for a compositing or anaerobic digestion, produces biogas. This prevents the methane emissions and creates the renewable energy. So this is one of the best method how we can make the organic recycling is one of the best way. So this one is the metal recycling. Next is the organic next to how to generate waste to energy. That is the waste to energy is one of the important concept nowadays as per the SDG. You have to think about. So these are non-renewable waste is incinerated to recover energy. Emissions are control are essential to prevent the air pollution. So then we have the sanitary landfillings. So sanitary landfill is one of the important aspect you have to consider, which can be reduce the liners and leachate control. So it should be after maximizing the recovery should be contained. So these are some of the waste management methods should be considered to manage effectively and collect the waste and final disposal. So coming to the source, step number one, stops source segregation of most first step, effective step in waste management is to segregate the waste. So the one is the green bin. We have to understand the wet organic waste, food scraps, vegetables, peels, gardens waste, and cooked food. Whereas the blue bin is about the dry recyclable papers, cardboards, plates, plastics, glass, metals, and tetra packs. So then is the red bin, where is the hazardous waste, which is to be understand. So it should be rejected diapers and sanitary napkins, broken glass, toxic item. Next is the yellow bin, which is to be given for the biomedical waste expired in the medicines or shops, whatever it may be. So these are some of the source segregation according to the required level of different types of industries which is adopted. So what will happen, we can reduce the contamination of the waste, and we can increase the recycling rate, we can lower the treatment cost also when you do the step one process in a perfect way. That is one of the thing we have to consider. Next one is what are the step number two is involved with the material recycling process. So in converting the sorted waste into new products. So what is the first step is the collection and segregation. So dry recyclable collected from the households, industries, or bins and manufacturing units. So then you go for the sorted techniques where you can go for manually or automated optical sorting, washing and remove the contaminants. Then you have to process that waste into shredding, whether it's a plastic waste or plumping paper or melting metals or glass or pelletizing plastic. So once you do carry out all these things, then you have to think for the remanufacturing of processed materials made with new products like bottles, package, country construction materials. So then you have to search for the market and distribution, how we can sold the recyclable products to be sold. So completely we can circular economy will becomes in a loop. So this was one of the best method of adoption for the circular economy. So then challenge is there here in this material recycling. What is the contaminated or mixed plastics often face lower value of recycling and rejection. So we have to think about that. So next we have the organic recycling, which is most of the uh, thinking how we can recycling the organic waste like biomass. So compositing and anaerobic digestion is one of the important aspects should be considered. So what is compositing? So composite is an anaerobic decomposition of organic matter, so which produce the nutrients rich composite to the humus. It is suitable for garden, food and agriculture waste. So decentralized was household, community and municipal scale. So we can get it out. So reduce the landfill and methane significantly. Composite used for natural fertilizer for the agriculture products. So this was called as the composting method. When is the anaerobic digestion or biomethanation? So when you think about this decomposition in the absence of oxygen, which will produce the biogas. CH4 plus methane plus carbon dioxide will comes as the renewable energy. It's called as the biogas. So once you digestate this residue, use it as a soil conditioner. So once this soil conditioner happen, it will prevent the uncontrolled methane from open dumps. So it is suitable for the food waste and sewage sludge. So most of the case sewage sludge is used for the biogas, that is called methane plus carbon dioxide, can generate electricity and reduce the greenhouse gas emissions into the atmosphere is one of the best advantage of dealing with organic recycling. So next one is about the waste treatment. Waste to energy and sanitary landfilling is to be considered. So where waste to energy is reflect that. So non-recyclable compostable MSW incinerator is in the control facilities. So it can be thermal energy to generate in the steam electricity. That is one of the best way. So then we have to control the emission controls can be mandated to prevent the air pollution like so amount of nitric dioxides are liberated to the atmosphere. So from this waste to energy, we can reduce the waste by volume up to 90%. When you think about the waste to energy before landfilling, that is one of the best way. Then must be only used for maximizing the metal recovery. So Ghaziapur waste to energy treatment plant, Pune plant is one of the basic plants which are situated to get the waste to energy and sanitary landfilling. Coming to the sanitary landfilling, as we know that landfilling is one of the contaminated, which will be contaminated most amount of the land. So we have to address these issues, as the sanitary landfilling is not an engineered disposal for residual waste that can be recovered. So HDPE liners prevent the leachate from the contaminated groundwater is one of the aspect. So leachate collection and treatment systems is mandatory, so we cannot release into the ground. So then we have the landfill gas capturing for energy for flaring. So which could be resort and after all recovery options exhausted. So poorly managed dumps and groundwater pollution, methane leaks for because of the sanitary landfilling. So we have to understand how we can effectively process it. So then we have the plastic recycling and what are the types and challenges incorporated in this plastic recycling. So first one is the PET. Highly recyclable is the water bottles, fibers and the new bottles, and that is called as the PET bottles. And next one is the HDPE bottles, so like milk jugs and pipes and containers. So this is one of the HDPE2. So then we have the PVC, rarely recycled pipes and fluorine toxic additives. Then limited recycling is about the LDPE, that is the limited recycling act, that is the plastic bags and blins liners. So often recycle is the containers and package. Then rarely recycle is the styrofoam and major pollutant. Usually not will do for the mix and multi-layer. Very difficult to go for the recycling. So the different types of plastics are situated where you have to think about how to recycle that one. So global plastic recycling rate is about 10%. So India collects around 60% of plastic, but effective recycling is much lower because of there is no proper treatment and proper processing of the plastic into the useful, unless at all it is used for a bitumen road manufacturing. There should be a highly technology which will be recycle this plastic into the new products, or as well as to produce the energy. So, and then coming to the address to the biomedical waste management. So this biomedical waste management is going to be situated safe handling from healthcare facilities. So it is sharps, needles, or scalpels and lancet, broken glass is one of the threat. So we have to address this one in a better way. So autoclave method or shredding method or needle destroyer is one of the best way to treatment method. Category is infectious. So blood clusters and pathological substance. Autoclave or incineration about 850 degrees Celsius is one of the best method. Next, third one is about the chemical disinfectants and lab chemicals and mercury, so which will give the chemical treatment as well as the secure landfill. So then we have the pharmaceuticals. So pharmaceuticals, expired medicines and synthotic drugs. So return to manufacturing and incinerations. So general what we will talk about is non-infectant soil waste from wards. So municipal solid waste have the route where we can consider that how we have to recycle, and we have to think about a 754 tons of one municipal biomedical waste is generated from every year of 2023 census. So governed by the medical waste rule, which is governed by the 2016. So we have to understand what is the scenario, how to recycle this biomedical waste into effective way. So that will be the best solution of the considering the how we can go for the recycling, that is the triple R formula, or reuse, or we can go for remanufacture or reproduct, whatever it may be. So we have to follow the triple R formula is one of the best way to think about the circular economy. So this is one of the best way. So next is about the industrial waste management. So industry means there are several industry, we have to think about the thermal major composition which is coming from the thermal power plant is the flash and bottom ash, these two things which will be considered, and they should be understand the how we can recycle. Already the fly ash was used for large amount of manufacturing of several cements, as well as dumping, as well as we can go for the fillings of the road embankments, recycling into cement bricks and road construction. India manages 100% of fly ash utilization. There is no problem with no fly ash. Only there will be chances to for the fly ash we have to manufacture the power maybe in future, because of we are going for renewable energy in maybe 2050. So next one is the construction debris. So crushed concrete recycle as aggregate, wood recovered metal slaved from scrap markets. So these are some of the construction debris. Already there are a lot of research is done on the how we can effectively use it of different recycle aggregates into the concrete and recycle it, and again you have to use it. So maybe there is a lot of waste has decreased now. So then is the chemical and effluent waste coming from various industry. Effluent treatment plants should be mandatory for industry zones, and zero liquid discharge should be policies should be tightened. Why? Because when you discharge the liquids into the open source, there will be a contamination of the local body water as well as the oceans. So you have to think about the before releasing into the ocean, you have to treat it and release. When you're then the aquaculture will be better, and ocean culture is underwater sea is also very better. So next is the textile industry waste is one of the threatening way. So because of high effluent dyes treated via reverse osmosis and biological treatment, fabric waste used for recycling the fiber. So this is one of the thing we have to think how we can manage the textile industrial waste. Then we have the packaging waste. As we know that so a lot of companies has come into the picture, reduce the plastic packaging. Now they are depending upon the packing with the cartoon that cardboard. So extended procedure responsibilities of rules make the brand responsible for collecting and recycling their package. Yes, when you think about the delivering parcels as well as any packaging was done, they nowadays they change a lot. They are using most of the cases they are using only the cardboards. So that will be the one of the best way. Then was the metal scrap as well as the e-waste. So formal e-waste recycling sector growing nowadays, but still there is a process metal of recovery, gold and palladium and from the circuit boards. Then only they are then after that they are throwing somewhere, and that is will be the contaminating the soil. So we have to think about how we can effectively manage this industrial waste management. Then how we can integrate this all the waste management into AML applications. Why I'm saying this, nowadays as you know the data collection and data sorting of all these things we have to depend upon the AI strategicals. So this you have to maintain a proper managing of this waste. So then we have to depend upon the waste management to AI. So how we are going to depend upon AI integration is one of the best way. So you see here enhancing the efficiency and accuracy, simply sorting out recycling process which is reduce the environment as well as the impact effectively. Then you have to think about the what are the startup opportunities, the circular economy posting about the management. So inefficient waste handling will be highly environmental impact and as well as the low sustainability. Sustainable waste management will help us to reduce the impact as well as improve the circular economy. So when you integrate this AI implementation in the smart integration like Vision AI identifies and sorts materials within 90% of accuracy will be done. Route optimization. So ML based algorithms cut the fuel and collection of the cost by 30% by identifying the route of where the waste is going to be collected. Then predictive modeling forecast the waste volumes using population growth and the consumption data, which will help to identify how much amount of waste will be generated in the next coming years. So that is the one of the best way of tackling of this AML based waste management. So then we have the industrial monitoring. So anomaly detection in effluents and chemical waste streams. So you have to understand how the industry will monitor the waste liquids where it is releasing to the effluents to the streams. We have to identify the monitoring through AI based monitoring, that IoT technology. So these are some of the important aspects we have to think about how to integrate this AML into the waste management scheme. So one of the best way are going to transforming our inefficiency into the intelligence. So that is the one of the best way. So we have to think about that. So then we have the AI powered smart segregation system. As I earlier discussed, how we can segregate the smart vision and robotic sorting at different manufacturing units. So you can see as computer vision is one of the best way, which in installing of cameras, deep learning, CNN, YOLO identify waste type from images in a real time. This is the best way where you can get the accuracy of 90 to 95%. So computer vision based waste segregation is one of the best way. So near infrared sensors, that is also one of the best way. Identify the polymer types like PET bottles such SDP plus BP on conveyor belts at high speed. So this will be having the accuracy about 98 plus percentage. Robotic arms cobots. So ML guided robotic grippers pick up the specific material up to the 60 80 picks per minute. It will be give the accuracy also, that is 85% to 62% of segregation the waste material. Then eddy current separators. So this will be help us to electromagnetic separation for non-ferrous metals like aluminum from the waste stream. So companies like AMP Robotics as well as Greyparrot and Nepra Resource Management India, so already they have incorporated this AI powered smart segregation system, which will be already they have done with the at an accuracy level of 95%. So this is the how we can integrate this AI powered smart segregation process into the waste management. Definitely, it will be a very high level benefits will become. We cannot go on the continuously because of unhygienic metals may be there. So we have to think about the human health and that process. So we have to it's better we have to integrate the robotics into the smart segregation system in the waste management, which will help us to properly do the waste segregation process. So this how the AI integration will be help us in the solid waste sustainable solid waste management. How a resource will be recovered from this one. So then we have the IoT and the smart bin technology. As the IoT integration is one of the best way. So this will be happens on the data driven waste collection optimization. We can identify easily. So you can see the fill level sensors. So ultrasonic sensors monitor bin level fills, whether when it immediately fills alter the scent. So definitely there will be 70% of immediately will go there and prevents the overflow, reduce the unnecessary trips. And next we have the route optimization also. So there will be a GPS and IoT data fed to route planning. So which algorithms will be there. Then we have to identify the dynamic route actual fill levels. We can efficiently we can save the uh, collecting vehicles fuel. That is save 30% of the fuel can be saved by integrating of this IoT based smart bin technology. Next one is about the temperature and the gas sensor. So how it will be detect the methane H2S from organic decomposition. So fire risk alerts from landfills ensure the worker safety is very important. So it will trigger the temperature as well as the gas sensor. So there will be automatically dashboard analytics should be replaced. It will be provided at the different boards stating that this dustbin was filled and city level waste and analytical platforms. So tracking and picking the generation times and sector wise data for planning, it will be better way how we can plan the dashboard in a proper way to collect the waste and waste management should be done. Then there should be a citizen map should be available. So mobile apps for schedule the alerts, missed the collection complaints and segregation of the reminders and recycling points locator. So this will help us to monitor very quickly and we can minimize that waste which is contaminating the local communities. Next one is about the blockchain tracking system. So, immutable record of BMW from hospital to treatment, which will prevent the illegal dumping and ensures the compliance about the audit trail. So, these are some of the IoT and smart bin technology. As I earlier told, we talk about the AI segregation process, then how we are collection process also we have to integrate with the IoT and smart sensors. This how we can effectively manage the solid management of the solid waste management in a proper way. That is will be become a sustainable waste management. This was one of the best technologies we can organize, and we can get the best of that. So then how to get the predictive waste generation models in a proper way? When you think about the prediction models in Indian municipal solid waste generation trend, it is 0 trillion pounds there. When you see in 2015 it is around TPD of 110. Where you go for the 2030 years, 2030 it will goes 230 TPT. So what is going to be happen when you predict this sort of things? And there will be a trend we have to understand is a linearly increment in the municipal solid waste. So maybe the input variable we can consider using ML to forecast the waste volume to optimize infrastructure, like input variables like pollution, population, GDP or per capita demand, urbanization rate, sensational seasonal patterns, event calendars. These are some of the important parameters should be considered for estimating how much amount of waste will be generated in the future. So machine learning algorithm like LSTM time series, random forest, XGBoost, or multivariable forecasting will help us to get the machine learning algorithms. What is the output here? So this output is a predicted daily week waste volumes per zone and seasonal peaks as well as the material composition. So this will help us to integrate how the output is predicting properly or not. Then when you are going for application, fleet seizing, facility capacity planning, budget allocation, infrastructure investment, all these things will help us to get the proper predictive model for estimating what it could be the next year, what could be the higher amount of capacity. Based on that, we can prepare the order the vehicles and IoT sensors as collection, segregation. That will be the best method of predictive model. That was the how we can integrate the AI into the sustainable waste management. So the coming to the AI plus blockchain for medical solid waste water tracking system. So once the hospital was generation, so then we have to go for the segregation, packing, labeling, or QR coding, authorized transporter, treatment facility, then disposal and certificate that. So QR codes will be given on each waste bag. Every bag to be logged at generation, weight, category, hospital ID, and timestamp. So then blockchain leader, immutable chain of custody from hospital, transporter and treatment facility cannot be tampered. So then you go for the AI compliance monitoring system where you can monitor the ML flags, delays in the transit, missing treatment confirmations and abnormal volumes. So regulatory dashboards should be provided whether the CPD as SPZ authorities are get a real-time visibility, reduce the illegal dumping up to 60% of this biomedical waste tracking system. So that was the main important. Every industry should be having this AI blockchain for medical. Every generations of the waste should be considered. So next we have the circular economy, how to integrate in the solid waste management or sustainable waste management. So when you talk, I already told, whenever you think about the circular economy and waste management, so you have to shifting from linear take, make to dispose and to the circular loop. So linear economy extract, manufacture, use and dispose only. But when you think about the circular economy loop, materials stay in economy. So design for reuse, manufacture it and use and maintain and collect and recover, again recycle and remanufacture. This is the best way to go for the circular economy loop rather than going for the linear economy loop is the worst thing. We cannot go for that. So 4.5 trillion circular economy opportunities there by globally at the 2030 by 30. So 50 to 80% of the reduction in the raw material extraction possible, and 30% will be lower by the greenhouse gas emissions versus linear economy. So millions. So newer green jobs in recycling and remanufacturing. So these are some of the best practices we can incorporate into the sustainable waste management through circular economy. So coming to the startup ideas, which has in which has came into the picture. So, like AI driven smart bin systems. So, this is one of the best AI based startup idea. So, where you can go for the technology product for municipalities and corporates, where their fill level sensors should be ultrasonic and AI camera for a waste type of recognition, real-time data to cloud dashboard, automated collection alerts should be given to the driver or vehicle. So solar powered option should be given. Then we have to target for the markets, municipals and smart cities, gated communities and rural welfare authorities, corporations like IT parks and factories, hospitals and healthcare facilities, airport, malls and transit hubs. These are some of the target markets where we can integrate this AI-driven smart bin system. So then what is the business model you have? You can have the hardware sale plus IoT subscription, then SAS board or per bin per month. Data analysis will be situated. So then we have the reporting services, data analytical reporting services, carbon credit revenue sharing will be given to the authority who have startup. So then we have the government smart city tenders. So we have to think about this is the revenue generation about who have startup. This is called carbon credit. So we are decreasing the carbon. That means we have to pay. The industry should pay to us. So government smart city tenders will be come up to this. So this is one of the best startup idea to get into the line, and we can get the how we can effectively we can manage the waste management. Then with the startup to about the landscape in waste management, that is one of the best six high potential business opportunities. This one only nowadays. So where we can look at the smart bin systems here. So marketplaces where municipalities and corporates will take for IoT plus AI vision. So then segregation robotics will be given, like recycling plants or manufacturing units, computer vision plus robotics, and circular economy marketplace like industries and B2B digital platform and machine learning matching, and biomedical waste tracking app, hospital and CBC, blockchain AI compliance, recycling plant optimization, reclayers, cement and COS, and machine learning yield prediction will be given for the recycling plant optimization. So finally, we'll get the correct carbon credit verification, corporates and governments plus AI plus satellite monitoring will be adopted. So this is the best way to how we can utilize these startups in the waste management. So then we have the policy and regulatory framework in India. So why I'm talking about India? This India we have to develop a lot because we are not integrating of AI technologies into this sort of aspects. So what is the ongoing process? We will be discuss about the key laws and mission driving waste management compliance in India. So first we will discuss about the Swachh Bharat mission. So Swachh Bharat mission is national cleanliness mission, which is to focus on the processing of waste, capacity and OD plus, and solid liquid waste management in rural areas. So solid waste management rules like mandate the source segregation, wet and dry hazardous, extended procedure responsibility, and prescribed treatment for different waste streams like amended in 2024. So then we have the plastic waste management rules to be adopted, which is amended where EPR framework for the plastic packages, project importers as well as the brand owners. So then we have the biomedical waste management rules, classification, treatment, and the disposal standards. How we are going to healthcare facilities, CBS, PB, SPCB oversight, and other authorization mandatory. So then we have the e-waste rules, e-waste management rules. So producers responsible for collection of targets, formal recycling channels required, penalties in informal sector disposal. So these are some of the policies which are integrated in India. So that will be help us to get into the line of the solid waste management, that is sustainable waste management and resource recovery. So which will help us to trigger in each and every aspects that will help us in a better way. So all of you are responsibility, individual responsible to integrate this AI modeling of AI prediction and based on the IoT based sensors and beans and waste management in a proper way. All industries should be integrated about this managing of this waste in a proper way. This separate sector should be, this separate office should be there for every industry, and how effectively you can manage the waste which is coming from the different industries. So then we have the global case studies in waste management, whereas the Singapore is almost having the 60% of waste recovery rate. It was the Simoca landfill, waste to energy plants are there, NEA digital waste tracking, and EPR from the e-waste and packaging. So this was the one of the best way how we can do it. And here we have the recycling rate of 67%. So advanced dual system like Brunner Patent and deposit return scheme, strict producer responsibility and global benchmark. Sweden is 1% only waste to landfill. So import the waste from energy, 50% plus waste to energy deposits and EPR losses, circular account deeply embedded. That was the main important criteria. In Japan, it is around waste to open dumps is zero, whereas the strict 34 categories starting in kamikazes to waste to energy plants processing is 75%, and municipal solid waste is net zero landfill in the societal goal. So Japan is one of the best role model where we can access and get the best of the waste managing criteria in global way. So we have to understand how get the learning the best practices around the world. So this is the one way where you can manage effectively about the waste generated from the different industries. So which is the some of the case studies. Then Indian case studies and success stories was clearly given where you see about the Indore in Madhya Pradesh, one is the cleanest city, 7 into X, where the 100% of door-to-door collection, source segregation, decentralization, and national benchmark for the solid management. So, wherein model for India, Kamikats to 85%, 81% of recycling rate is there, inspired by Indian initiative by hyper segregation. So, divided into adopt the pilot municipalities. Pune, Maharashtra is the Katgat Kach Patar Kastkari Panchayat. So rack pickers, corporate to formalize 3,500 plus waste workers are working formal integration into informal sector. So in Ghaziapur, as I earlier stated in the case study, that is the waste to energy in Delhi, 12 megawatts power was generated. So first operation is to waste to energy plant in India. 2000 TBD capacity was generated. Lessons from this emission control and community impact. So ITC zero waste to landfill corporate model. So ITC achieved zero waste to landfill across the manufacturing until 98% of the recycling rate EPR compliance leader. So these are some of the success rate in India. So still we are not at all improved in a better way. Different sectors should be incorporated. We are focusing on municipal only. There are a lot of industries, chemical industries should be focused about the setting about the how effectively we can manage the waste. So when you think about the economic opportunity in waste technology, we can see here global waste tech investment is increasing day by day in billions and billions. So 4.5 trillion circular economy market by 2030, record highs for clean tech and getting the climate tech investment. So tighter rule is there, EPR and solid waste business, biomedical waste as well as the plastic rules enforcing compliance. So 2030 goals is India 100% waste processing, zero single use plastic. So these are some of the best way how we can make economic opportunity in waste tech. This is the best way to improve our economy by utilizing the waste management in a proper way. So then obstacle will be there each and every waste man in India and globally. One is the behavioral. So low public awareness and segregation procedures and resistance to changing habits. Informal sector disorganization. So inadequate collection vehicles are there and lack of MRF capacity ties of 2 to 3 times. Poor landfill management standards are situated. So technologies like high chemical cost is there, but AI robotic system should be integrated. So limited digital literacy in the working force, data grabs of effective modeling. So policy and finance, fragmented urban local body capacity and underfunded waste management budgets, which is no use. So weak EPR enforcement and mechanism. These are some of the challenges which are facing to manage the solid waste management or sustainable waste management should be considered. So then we have the future of the waste management should be we have to integrate with the emerging technology and trends to watch. Whereas autonomous waste collection, where you have to think about a self-driving collection of vehicles navigating, enzymatic biorecycling process where enzymes are break down into molecule level 100 into X faster than a conventional recycling. Satellite drone monitoring system should be adapted. We have to maintain the remote sensing, illegal dump detection should be there. Landfilling, gas monitoring, and large scale waste mapping should be adopted. So then we have the waste to hydrogen energy development, converting non-recyclable energy into green energy through via plasma gasification technology should be emerging as the clean energy pathway. Digital waste passport should be given. Product level tracking of materials through life cycle, enable sorting, repair, and end of the life route. Advanced the biomedical waste treatment should be given. Microwave sterilization, plasma arc treatment for biomedical waste, software cleaner that incinerated ash should be done. So that is how we can manage that future of the waste biomass. So one of the best case studies in this presentation is about the waste in global crisis 2.24 billions per year. Municipal solid waste globally and India alone generates the 1,60,000 TPD. Scale demands urgent action here. And source segregation is most impactful first step. Wet, dry, and hazardous dramatically improves the downstream outcomes. Hierarchy exists: reduce, reuse, and recycle and recover energy. Landfill last resort. Follow this order. So AML integration into the waste management from robotic sorting to predictive models and IOS enabled smart bins. So circular economy thinking is the future, turning the waste into resource, jobs as well as the business worthy for trillions of the income can be generated. So then you have to integrate with the policy implementation, technology and public behavior as the must align. No single solution works without others. A system should be approached essential. So these are some of the where we have learned in this session. I hope you all people understand. These are some of the references. So try to integrate all this management individual houses to the municipal solid waste system as well as the biomedical waste system as well as the industrial waste as well as the chemical industry waste. So try to understand the concept carefully and integrate and think about the how we can reduction of all these things in a proper way. Altogether integrating is called as the sustainable solid waste management. It's called waste management system in a proper way. Thank you for viewing this YouTube video. Please subscribe and like my video if you get very best of knowledge, and we can have the discussion about this session. You can go with my contact details, and you have the email ID as well as the LinkedIn profile, and you can go with that, and you can contact me in anywhere, either email or you can contact with me in the LinkedIn messages. Thank you. Jai Hind.